All right, 6.5 is another small section, and it just talks about, what is probability? Your book says that there are several competing ideas which seek to define the interpretation of probability, similar to the competing ideas which define the notation of central tendency, mean, median, mode, trim, mean. In fact, there is a substantial conflict of ideas between the notations of statistical regularity and degree of belief. No simple answer exists for the question, what is probability? So, probability is truly an abstract concept for which there is no meaning. However, there are some laws, I guess you could say, that we use that govern probability. And so those laws are listed in the next section in 6.6. A probability of 0 means the event cannot happen. Alright, so if the probability of something is 0, that means it can't happen. I'm sure most of you already knew that. So the probability of tomorrow being March 32nd, that can't happen. Or the probability of us not having homework on these couple sections, that's pretty much 0. Whether you do it or not, it's your choice, but you will have homework on most of these sections. So alright, so a probability of 1, this is the probability of us having some homework, means the event must happen. Alright, so the probability that something is certain or must happen is 1. Every probability must be between 0 and 1, and it inclusively, meaning it can be 0, it can be 1. So if you're ever working a problem out and somehow you get a negative probability, then you know you messed up. Or if you get something that is greater than 1 when you divide, if you're finding the probability by the classical approach and you get 1.2, then you know you messed up, because all probabilities have to be between and including 0 and 1. The sum of all probabilities must equal 1. So the probability, let's say, of having a boy plus the probability of having a girl must be equal to 1. If you wrote down all the probabilities for rolling a single die, the probability of getting a 1 plus the probability of getting a 2, so on and so forth, if you add all those probabilities up, you're guaranteed to get 1. Exactly 1. Okay, so how do we actually connect probability and statistics? What is there that we can use, or why would we want to make some type of connection between the two? Most of the time, statisticians working with samples try to deduce from the samples the population parameters, meaning the means, the proportions, the variance, things like that. The process of making those judgments about the population parameters is called statistical inference. Because samples are random, there's no guarantee that the sample will be representative of the population. If the sample is not representative, then using a sample mean as a guess of the population mean would not be very wise. Probability is used to assess the quality of our inference. All statistical conclusions must be endowed with a degree of uncertainty. Because probability is used to assess the reliability of sample inferences, it is the foundation of all inferential statistics. Because probability is used to assess the reliability of sample inferences, it is the foundation of inferential statistics. Just read that straight out of the book. So that's the connection between the two. .8 is another one of those small sections. It just makes a connection between probability and business. It says the probability concept has many direct applications in business: designing and evaluating product reliability, evaluating insurance. And that's how companies figure out, that's one of the determining factors on how they figure out how much to charge people. Inventory management, project management, queuing theory.